The three major functions that we're talking about at this point in time. First one would be linear functions, which we've talked about so far all year. The second one is going to be a new one, which is going to be our quadratics. And the third one that we're going to look at are going to be exponential functions. There's a couple different ways that these can be categorized. The first way we can look at it is if we just look at what the function itself looks like. A linear function is everything we have seen. That's our typical y equals mx plus b. So an example of that would be y equals 3x plus 2. What you don't see here is this exponent, but that exponent is really a 1. So I've got 3x to the first power. A linear function, then if we look at the table of values, is going to have for every x value, the y value is going to be increasing or decreasing whatever the slope is. In this function, our slope is 3, so we can see it increases 3 every single time. And exactly as we would expect it to, the graph of this function is a straight line. So our linear functions graphed are always going to be a straight line. The function itself is going to be in the form y equals mx plus b, or our x, the highest value in the exponent, is going to be a 1. And our table is going to have a constant increase of some certain value. Now for a quadratic function, the highest exponent is a 2. We can see here that x squared, 2x squared, is the highest exponent. Therefore, it's a quadratic function. We can see it says the highest exponent is a plus 2. Now, just by looking at the table, you've got to look at the second difference. So if I look at my first differences here, I don't really notice much of a pattern. Minus 3, plus 4, plus 5, plus 9. There's nothing constant about that. However, for all quadratics, if you look at that second difference, so the difference now between negative 3 and 1 is 4. Between 1 and 5 is 4. Between 5 and 9 is 4. Between the next step, it'll be 4 again. So our second difference is what we're looking at there. If the second difference is ever increasing at a constant rate, it's quadratic. And then the other way to know if something's quadratic is if we look at the graph of the function and we see that it's a u. Now it can be a u that is right side up, or at times it'll be a u that is upside down. But as long as we have a u there, we know that it's quadratic. And then our last function is our exponential function. Exponential function is exactly what it sounds like. The variable is in the exponent. So those ones stick out a little bit more than the others. If we look at the table of values is all increasing by a constant factor. So it's being multiplied by 3, by 3, by 3, by 3. The entire time we're multiplying that output by a factor of 3. Now remember, linear, we were adding it by 3. Exponential, we will now be multiplying or dividing by a constant factor. And then if we look at the graph is going to start very slowly and then increase extremely rapidly. Or another depiction would be if it decreased extremely rapidly and then bottomed out. That's going to be our exponential functions. And if we look here, we can go through a couple examples of that. If I just look at the function here, or the graph, if I look at this graph, I can see it's not a straight line, it's not a u, it is that exponential curve we have here. So this one I can call exponential. Next one up, I'm looking here, straight line, that one is linear, just like we've seen a dozen different times. And the last one we have here, you can see pretty blatantly that's a u, quadratic. So those ones aren't that bad. If I look at the tables now, if I want to establish what kind of function this is, I can look at for my y values, I can see each time from 100 to 10, I divide by 10. From 10 to 1, I divide by 10. From 1 to 1/10, I divide by 10. From 1/10 to 100, I divide by 10. So if I'm dividing by a constant factor, that one is going to be quadratic as well. This table I see here, my outputs, I'm adding 3, adding 3, adding 3, adding 3. If I'm adding a constant number, that one's an easy one, it's going to be linear. And then the last way that we'll have to distinguish them is just by what their function itself looks like. If I have y equals negative 2x minus 10, I can see my x value, the highest exponent is a 1, so I could say this one's going to be linear. For y equals 5/2 to the x power, I can see my variable is in the exponent, which makes this exponential. And the last one, I have 2x squared plus 5x minus 7. Since I have an x squared and that's my highest exponent, that one is quadratic. So all we're doing really right now is just distinguishing between linear, exponential, and quadratic.